Welcome to Knowledge Base. Let us look at this question that says, find the reaction forces P and Q at C and D in the figure below. Ignore the weight of the light object. This is the light object that is supported on two knife edges at point C and D. The reaction forces at point C and D due to the knife edges are P and Q. And that is what the question is asking us to find. Let's find the reaction forces P and Q. You can see that the 10 Newton force is also acting on the object as shown. All of the distances between the line of application of the force to any given point is also shown, or they are shown on this figure. So our aim is to find P and Q. If we look at this, it is a uniform object that is at equilibrium. For such object at equilibrium under the influence of coplanar forces, such as this, there are two conditions that must be satisfied for this object to be in equilibrium, and these are the conditions. 1. The sum of the forces in one direction must equal the sum in the opposite direction. In other words, forces to the left must be equal to forces to the right. In this case, we only have forces to the upward direction and a force downward. It therefore means that upward forces must be equal to downward forces. That is one condition for this light object to be in equilibrium. The second condition is that the sum of the clockwise moment about a point must equal the sum of the anticlockwise moment about the same point. This is a statement of the moment of forces. So the moments must also be, the algebraic sum of the moments must also be equal to 0 for us to have this object at equilibrium. So these two conditions are what must be met for a uniform object such as this to be in equilibrium. Now let's take the first condition. Sum of forces acting up must be equal to the sum of forces acting down. If that is the case, then P plus Q should be equal to 10. P is acting up, Q is acting up, we add it up and we equate it to 10, the only force that is acting downward. If there was another force acting downward, we're going to add 10 to that force. But in this case, P plus Q equals to 10 is the sum of forces acting upward being equal to the one acting downward. Now let's move to the second condition. The sum of the clockwise moment about a point must equal the sum of the anticlockwise moment about the same point. The moment must be taken about a point. So the first thing we want to identify is what point are we going to be taking the moments about. Looking at this object, you can take the moment about any point of your choice, but stick to a point you must have picked. It means we could take moment about point A, the start of the object. We could take moment about point C. We could take moment about this 10 Newton force. We could take moment about point D. We can even take moment about point B. Just pick a point and stick to that point. In this video or in this solution, I want to pick point C. In other words, we are going to take moments about point C. Now, if we consider point C, let us look at how each of the forces would be creating moments. About point C, this 10 Newton force will cause a clockwise moment. In other words, it will pull this rod, this uniform object to rotate like this about this point C. So it causes a clockwise moment. So for the 10 Newton force, it will create a clockwise moment. Let's look at the force of Q. The force of Q is like this. About point C, the force of Q will cause the object to rotate like this. So it means the force of Q is acting in an anticlockwise, will create an anticlockwise moment. So we can say that for the force of Q, the moment is anticlockwise moment. The moment of a force about the same point you are taking moment is 0. So the moment the force of P creates about point C is 0 because the force is just at point C. So we are not considering point P. Now we have chosen both clockwise and anti-clockwise movement. We can now come and equate them here. So from the second condition, taking a movement about point C, we can say the clockwise movement will be what? 10 times 2, the distance between the first and the point we've picked. So 10 times 2 will be equal to the anti-clockwise movement Q times 6 plus 2, because the distance from Q to the point C is 8. So we have 10 times 2 equals to Q times 2 plus 6. To obtain Q, we are going to divide both sides by 8 because 6 plus 2 is 8. So that Q will be equals to 10 times 2, 20, divided by 2 plus 6, 8. And that gives us 2.5 Newton. So the reaction force Q is 2.5 Newton. We need to find the reaction force P. If we put the value of Q into this equation, we can find P. So if we make P subject of formula here, it means that P is equals to 10 minus Q. If we put the value of Q here, 2.5, it means that P is equals to 10 minus 2.5, and that is equal to 7.5 Newton. So the reaction forces we are looking for are 2.5 Newton and 7.5 Newton, and it is very, very simple. Now, here is a simple one for you to do. Find the reaction force P at O, which is at its knife edge, if this light object is in equilibrium. You can ignore the weight of the object because it is light. Then put your answer in the comment section. I hope you enjoyed this video, and thank you very much for watching this video. Please like, share, and follow our page if you have not done so. And see you in the next video.